Desk. All right, so everything's, oh my gosh, every freaking time. Okay. All right, so square roots. All right. What's the connection between square roots and quadratics? Why do we care about square roots when it comes to quadratics? Say it one more time. Well, they're in the quadratic formula, but why would they be in the quadratic formula? It's the opposite of squares. That's the main reason. So, they're the inverse operations of squaring. That's why we care about square roots, because when we're solving quadratics, at some point we're going to have to tackle that x squared. How do we undo a square? We take a square root. All right? So, knowing how to simplify radicals is very, 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 very important. All right? So, yes. Right hand on the board. I got someone out. So, these are all perfect squares. What do I mean by a perfect square? Square root is a nice whole number. All right? So, you guys should know these. What's the square root of 25? 5. Square root of 9? 3. Why would the square root of 9 be 9? Square root of 100? 10. Square root of 0? We're not there yet. Riley, I know you know this. Not yet. All right. 1/4. What do you think? 1/2. So you can rewrite this as a square root of 1 over the square root of 4. So that's 1/2. So 64 over 9? 8/3. Because again, square root of 64 over square root of 9. So those are just basic ones. Now, so here's some ones that you need to know. I expect you guys to know all your square roots 1 through 20 by memory. All right. So in order: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, yep, 324, 361, and 400. So that is 1 through 20 in order, the perfect squares. You guys need to know that one from memory. At the very least, I expect you to know 1 through 15. And then the last 5, like those are, you just got to learn them. Why do you need to know that? Well, it'll make when you have to simplify radicals like 20 times easier if you know your perfect squares. Square root of 2? That's an irrational number. It's not a nice number. Nope, simplify completely. But some of them you can. All right, so I would write these down and just note that it is the squares of numbers 1 through 20 in order. Be warned, I may later quiz you on your perfect squares, so make sure you know them. And it'd probably be timed. Oh yeah, perfect squares.
We get 400 minutes.
No. You may get 400 seconds. I said you may. All right, now, So this is what Riley was bringing up when he was saying that we may need a plus minus. All right. So typically, what we generally know is that whenever we find the square root of a number, we default to the positive version. But technically, every square root has two versions, the positive and the negative. Because think about this. Because think about this way. Is it true that is it true that 3 squared is equal to negative 3 squared? Yeah. 3 times 3 is 9. Negative 3 times negative 3 is 9. All right. So technically, every perfect square has two answers to it. We just default to the positive one. Oh, yeah. So, So if I took the square root of 4, I would get 2 and what? Negative 2. Now, you don't have to write it like that every time. You can always do the shorthand, which is just using the plus minus symbol. So if you write plus minus 2, that means the positive and negative versions of 2. All right, so that's the mathematical shorthand, because math people, we don't like having to write a bunch of stuff if we can help it. So we shorthand a lot of stuff, trust me. Like some of the stuff I did in college, bunch of symbols, it looked like a different language. All right, if I took the square root of 36, how would I state it? Plus or minus 6. Plus or minus 6. 1 over 16, how would I state it? Plus or minus 1/4. All right. So get into the habits, especially when we're solving. This mainly comes into play when we're solving, because what's true about a quadratic? What's true about solutions of a quadratic, I should say? No, duh. Think about graphs. What's another name for solutions if we're talking graph? Zeros or roots or x-intercepts. So, how many x-intercepts can a quadratic have maximum? 2. Who said 5? So, they can have at max 2. That's where the plus minus will come in handy, because sometimes when you're solving, for example, if I asked you to solve x squared is equal to 36, all right, you would just take the square root of both sides. Your answer would be plus or minus 6. All right, so that would cover for the 2 square roots that I would have there. Okay.
So, like on the test, let's say like the answer was plus or minus.
If you don't put the plus or minus, or if you don't separate it, I will take points off.
So like half credit, like
depends on what it is. If it's short answer, yeah, partial. If it's multiple choice, USOL.
Can you explain what that means? I don't know.
SOL.
SOL. Like SOS.
Sugar honey iced tea out of luck.
Oh, I know what sugar honey is.
Think about what the letters of sugar honey iced tea. Take the first letter of all of them, put them together.
Alex got it.
I don't get it.
I know what it is. Yeah, I see it. Hello?
Something I said it.
There you go, Kirsten. There you go. Good God, y'all. Okay, now. Okay, now this next one. They gave us a function, and they asked us to find f of 46. What am I technically doing with that 46? Plugging it in for x. So we're finding x is 46. So I have 20 plus the square root of 46 plus 3. Now, technically speaking, the radical acts as parentheses. So we actually have to do what's under the radical first.
So that would be 49.
So what's 46 plus 3? 49. What would I do next?
Root it.
Square root it. Why?
Because it's under a square root. And you can't
You can't minus 20 from the square root of 40.
Technically, you can.
Not really.
Why
It's
does
like a math.
Why does PEMDAS say we have to? It's technically a singular number inside parentheses. Exponents, yes. Technically, and we're not there yet, but technically at some point you will learn to rewrite radicals as exponents. Radicals are considered exponents. So that's why by PEMDAS we do that first. So 20 plus 7 is 27. Now, technically, since it said plus, we use the positive version. All right, but what if I broke it apart?
Plus or minus.
So plus or minus 7. So I would have 20 plus 7, which is 27. And then 20 plus negative 7, which is what? 13. So technically, 2 or 4 is correct.
So it's on a test, which one would you choose?
In this case, since the guys, in this case, since the plus was already here, I would have defaulted to the positive one. All right, but just know that occasionally they may ask you for both answers, so you just gotta split it up.
So
I'm just showing that you can get either one, depending on if you break up the plus or minus.
You cannot be talking.
So what was the question?
it's from the f of x.
So it said f of x is equal to 46. So we're taking x equals 46, plugging it in for this x.
So where's 47?
Okay. Shh. All right. Now, this is where you're going to need your calculator. So here's an interesting property when it comes to multiplying radicals. So do me a favor. In A, do the square root of 4 times the square root of 9 in your calculator. So type in the square root of 4 times the square root of 9 in your calculator and tell me what you get.
3.464101.
No, it's 6. What are you doing?
You definitely did not get that out of the radical. You expanded the 4 radical all the way over. So,
You have to hit the arrow key to get it to 4 by 6.
so it is 6. Now, let's, guys. Now, let's look at this one. So if we're doing PEMDAS, we'll do what's under the radical first. So what's 4 times 9? 36. We got the square root of 36, which is 6. Now at this one, we would do the radicals first separately, then multiply. So what's square root of 4? Square root of 9? 3, still gets 6.
Oh, wait, so that would be 2 times 5. That equals 10.
So for right now, with simplifying, we're just worried about the positive. The plus minus doesn't really come in until solving. So just for right now, just worry about the positive. Technically, yes, but like just don't confuse yourself right now. So don't worry about the plus minus till we get to solving. All right. So what do you think happens? What do you think is true?
They're the same.
They're the
They are
same.
congruent.
All right. So even if so, what do you think the next one will be? So what's the square root of 4? Square root of 25?
5.
2 times 5? What's 4 times 25?
100.
Square root of 100? So, essentially, what this property is if you have 2 separate square roots with 2 numbers underneath them, It is the same thing as if you had a similar square root and you were multiplying those two numbers. And the reverse is also true. So if you have two numbers being multiplied under a singular radical, you can separate it into two baby radicals.
What would A be? Well, because it's like two.
So A and B are just placeholders for the numbers.
It's like X. What?
So it's saying for any A and B are both numbers. So A is equal to a number, B is equal to a number.
No,
So
no, exercise 5.
We aren't there yet.
Okay.
You see where I'm going, though, right?
Good God, y'all. This is not that complicated.
Yeah, well, for me, it's
No, because.
All right, so
Choose an MP.
okay. Good Lord, I always end my day with chaos. That's all I'll say with y'all. Okay, so all right, so where this comes into play is when we have some unfriendly square roots. So look at letter A. As it stands now, if I did the square root of 2, can I do the square root of 2 and get a pretty number?
No.
Can I do the square root of 8 and get a pretty number? No. So the easiest way to do this is to rewrite this as a square root of 2 times 8. Because what's the square root of 2 times, what's 2 times 8? 16. So we have the square root of 16. Is that a perfect square? Yes. So that'll be 4. So what about this next one? So square root of 12 times 3, which is what? Not just 36.
36 square root.
There's square root of 36. All right. 36 and square root of 36 are two very different things. What's the square root of 36?
Are these still plus or minus?
Okay, so guys, with the plus or minus, I showed you that just so it's in the back of your brain for solving. For over there. For right now, we're not going to worry about the plus minus. All right, the plus or minus will come into play when we start solving. All right, so it's more so just to put in the back of your mind, just so you'll have that little nudge when we get to it. All right, but for right now, just worry about positive. Okay. This one. So be 20 times 5, square root of 100, which is what? 10. Now, do we have to rewrite it like this every time? No. All right, you could just do 20 times 5, just know it's the square root of 100, not 100, and then equal to 10. All right. Now, why is this important? This comes into play when we start simplifying non-perfect square roots, meaning that no matter how hard we try, we are not going to get a pretty number no matter what we do. All right. So simplifying square roots with non-perfect squares. All right, so let's see if y'all can list your first 10 perfect squares. So what's the first one? 1, then
36.
then
64.
then
81. 100.
and that's it.
That's
That's the first 10. So they just want the first 10, so that's what we listed. Now remember, I want you guys to know the first 20. All right. At the very least, you need to know 1 through 15. At the very least. All right. So now let's consider this square root of 18. If we put the square root of 18 in our calculator, would it give us a nice, pretty number? No. It would give us an ugly looking, don't want to touch it with a 10-foot pole decimal. All right. But what does 18 contain that we could take out? 9. Why 9?
because it's a perfect square and you can classify it.
9 is a perfect square. So we want a perfect square that's a factor that divides into 18, and that would be 9. So I can break 18 down into 9, which is a perfect square, and what? 2. 18 divided by 9 is division.
Yep.
So why does that transfer in? Because now when I simplify, I can rewrite 18 using these two factors. So I can rewrite 18 as the square root of 9 times 2. Now, based off of what we just learned about multiplying radicals, what could I do with that radical? Break it up into two different radicals. So square root of 9 times the square root of 2. Now, is there something very nice and easy that I could simplify?
No.
Square root of 9, which is 3. So this is 3 times the square root of 2, which if we pretty it up is 3 square root 2.
Nothing.
That's your answer. That's a simplified radical. Now, don't believe me? Take a minute, put the square root of 18 in your calculator, and then put 3 square root 2 in your calculator. See if you get the same thing. So if you put those two in your calculator, do you get the same thing? Yeah. Now, why do we even need to simplify radicals? It's more of an antiquated skill, but when it comes to things like solving quadratics, we want our answers to be as exact as possible. We are no longer rounding. All right. So we are going to keep them in radical form, but we also want to be simplified to the fullest so we can kind of get an idea of what the radical will look like. Because now, let's think about it this way. If I asked you to tell me the two perfect square numbers that 3 square root 2 is between, what would you tell me?
9.
So let's think about this logically. We know the square root of 9 is 3. So at the very least, square root of 18 is going to be greater than 3. All right? Square root of 2. Where do you think the square root of 2 would lie? Between which two perfect squares? 1 and 4. So if I multiply 3 to either one of those, all right, where do you think it would lie?
Yeah, 16 and 25.
16 and 25. So in other words, it should probably be about 4 point something, or it should be greater than 4, less than 5. Is it like 4 point something?
Yeah.
Yep. That's how you can kind of guesstimate where it's going to land. So to simplify a radical, it's actually pretty easy. You first start by finding the largest perfect square that's a factor of what we call the radicand. The radicand is a fancy name for the number that's under the square roots. So, for example, square root of 18, the radicand's 18. So, what I always say is look at the original and figure out what would be the highest possible square root that you could divide into it. Not that you can divide into it evenly, but what you could possibly divide into it.
4.
So like for 8, I can't go past which perfect square?
4.
4. All right, because the next one's 9. We know 8 divided by 9, that's not even a whole number, it's a fraction. All right. So that leaves me with two options, 4 and 1. What's the only one that works?
4.
Or the highest one that works is 4. So 4 and 2. Then you rewrite it as 4 times whatever other factor. I always like to put the perfect square first because when it comes to simplifying the radicals, when you do take that square root of the perfect square, I want that nice whole number at the front.
Wait, so would it be 2 and then the square root thing and then 2?
So 4 times the square root of 2. So yeah, square root of 4 is 2 times the square root of 2. So guys, just so you're aware, in terms of precision, the whole number, so this square root of 4 value, the reason I put it first is because this 2 should go first. It always is going to be on the left. So every nice number you get when you take the square root of the perfect square, it always goes on the left of the radical. All right, don't put it on the right. That's just not how you do it. Let's try another one. 45. What?
36.
5 and 9. Okay, so 9 and 5. So 9 times 5, square root of 9 times the square root of 5. What's my answer?
3 square root 5.
Yep. Now, think about this carefully. I want the largest perfect square for C. 12 and 4 is one of them, but isn't necessarily the largest.
16.
16 and 3 is. Now, you could use 12 and 4. The only problem is that you'd have to simplify the radical again. All right, it won't be fully simplified. So, I'm going to show you both ways just so you guys know what happens if you run into that problem. So, if we do it right off the bat, 16 and 3. Square root of 16 times 3. So it's square root of 16 times square root of 3. What's my answer? 4 square root of 3. Now, let's try it this way, but with 4 and 12. So I have the square root of 4 times 12. Square root of 4 times the square root of 12. What's the square root of 4?
2. But then you'd have to do
But
it
does 12 still contain a perfect square factor?
again. So it would
Yep.
be
So we got to do it again. So this would be 4 and 3. So I still got the 2. It still exists. Times square root of 4 times square root of 3. This would be 2 square root 4 times square root 3. Square root of 4 is? So this would be 2 times 2 times the square root of 3. So that'll be 4 square root 3.
Why would you even do it? Why would you do this?
No, if like you didn't get the largest one.
So what I'm saying is that if you didn't get the largest one, you don't have to erase it and try again. You just need to simplify the radical again. All right? It does happen. That's why I say start by dividing the biggest one first. So for 48, if I was using 48, what would be the first perfect square I would try to divide into 48? 36. All right, so start with 36 and go down. Whichever one's the first one that you get when you go down that list, from biggest to smallest, that's the one you use. All right, so you'll hit 16 before you hit 4. 18 and 2, neither one of those are perfect squares. And remember, there are going to be factors of 48 that neither one of them are perfect squares. You should not even consider those. You have to have one of the factors be a perfect square. If it's not, you don't even need it. All right. Look at letter F. Now, it's a little hard to see, but there is a negative on the outside. That just means that whatever our answer is, we're going to have it to be negative. So 500, what are the two? 105. 25 would have also worked, so make sure you use the biggest one. So this would be negative 100 times 5. So negative 100 times square root of 5. So what's my answer? Negative 10 times the square root of 5. So it's negative because it was originally negative. You just keep it there. All right. Okay, there should be a new Delta Math, and the notes should be posted by the end of class. All right, so try D and E on your own. So try D and E on your own.
So start by dividing 2 by 5. So that's about 75. What would be the highest one possibly? So always have to do this. What do you do with these other squares? 25 and 40.
Thumbs up if you're ready. Try some more minutes. While you're waiting, just talk to the group mates and got your answers.
You want to go back to primary? What the hell do you want? But we're still putting this I'll email you this that because I didn't actually.
Yes.
You guys both very nice. Because you do it. Yeah. 46 is a very different number than school too. Very sure we're
All right. Check your answers. Any questions on that? All right. Now, we're going to do the next section very quickly because this is a very quick section. Irrational numbers. So this is a whole new family of numbers. You may or may not have heard of it before. So, in the real number family, all right, which, by the way, we're about to exit the real number family very soon and enter the complex number family. All right. So, in the real number family, there are two subsets you can break it down into: rational numbers and irrational numbers. Rational numbers is where all of our regular numbers fall under. So integers, whole numbers, naturals, all of them fall under there. All right. Irrationals is kind of a tinier umbrella, but it probably has more numbers that fall under it. All right. There's actually more irrational numbers than there are rational. Okay. So typically, how we can tell the difference between a rational and irrational number. A rational number is any number that can be written as a ratio. Hence the root ratio in rational. And what's another name for a ratio? It's a what? Proportion, which is fraction. So in other words, you can rewrite a rational number as a fraction in some shape or form. So that can include any of these fractions here. Or if you were looking specifically at decimals, it means they have terminating, which means they end, or they have repeating decimals. So for example, who remembers the decimal for 1/4? 0.25, that's a terminating decimal. It stops after 2 places. What's the decimal for 1/3? 0.3 repeating. So it repeats. There's a clear pattern. Yes, sir. Now, an irrational number. Ir meaning not. It's not rational. So it just means that we cannot write it as a ratio of two integers. So no matter how hard we try, we cannot turn that sucker into a fraction. And it has non-terminating and non-repeating decimal representations, which just means it goes on forever and ever and there's no clear pattern. Pi. Good. The most famous irrational number is pi. 3.1415, etc., etc., etc. All right. So pi is an irrational number. Can someone name me another one? Square root 2. That's a rational number. Essentially, any radical that does not have a perfect square under it is considered irrational. All right. So square root of 3, square root 5, square root 17, whatever. All right. You'll also learn about in Math 3 another irrational number called E. Yeah, 2.78, something like that. All right. But you'll learn about that in Math 3. And yes, there's a number called E, like lowercase e. Because Euler, whose first name starts with an E, is the one who came up with it. So he's like, you know what? I'm just going to use the first letter of my last name. That's most mathematicians. All right. So well, pi is technically a Greek letter, but it's a number. E is a sequence of numbers represented by a symbol. Does that symbol being E? Because it goes on forever and ever. Because you need it for when you do logarithms, which is Math 3. Well, if any of y'all want to go into engineering, you better know Math 3.
I don't want to. So do I not have to take it?
We should just be exempt from.
Well, you also have an EOC, so if you want to take a 0 for an exam grade and not want to graduate. All right, so we're going to consider two different numbers. So 2/3 and the square root of 1/2. 2/3 being the rational number, square root of 1/2 being the irrational, and they're both less than 1. All right, so let's travel back in time to kindergarten. If I drew a picture representation of 2/3, how would I draw it? 3 boxes and shade in 2. Now, who remembers what the decimal representation of 2/3 is? 0.6 repeating. So a lot of times your calculator will round the last 6 to a 7. All right. Don't say it. Lord help me. I can't wait till that one dies. All right. But technically it's 0.6 repeating. All right. Now, do me a favor. Put the square root of 1/2 into your calculator and tell me every decimal place it gives you. So tell me what it is. So it should be 0 point something. Okay, start again, but slower. I just used the division.
7, 1, 0, 6, 7, 8, 1. Oh, it says 1.
You could have also do the square root of 0.5 if you don't know how to put the fraction in. All right, so now, guys, have your top lip meet your bottom lip and keep them there. Okay, so let's say I did the square root of 1/2. So the way I type in is I just do square root of 1 divided by 2. Same thing as 1/2. Now, if I try to turn this into a fraction, who remembers how I can convert to a fraction in your calculator? So you hit math, which is that key under the green alpha key, and then 1. Because it says frac, it will convert to a fraction. So it should be that. So if you hit enter, what happens? Nothing. So if the number is incapable of becoming a fraction, your calculator will just repeat the decimal again. All right, that means that this number is irrational. You cannot turn it into a fraction. So why can we not draw a pictorial representation of square root of 1/2?
Because it would be really hard to.
We can't make a fraction. We could, but we want it to be as accurate as possible. So it just won't be accurate at all. We can estimate it, but it's not going to be accurate. So we can't make a fraction. That's the biggest thing. Because it's irrational. All right. Now, we're not going to do this exercise, but let me just ask you this. With these square roots, you're going to tell me whether they're irrational or not. Basically, every square root of any number is irrational unless that number is a perfect square. All right, so square root of 2, is that going to be rational or irrational? Definitely irrational. Can anyone guess what two whole numbers that number will be between if you put in your calculator? 1 and 2, how do you know?
Oh, because you can't multiply 2 by itself to get 2.
Yep. 2 times 2 is 4, 1 times 1 is 1. So it has to be between the square root of 1 and the square root of 4. What about square root of 10? Rational or irrational? Irrational. What two numbers do you think it would be between if we had to guesstimate?
9 and 16.
9 and 16. So if we're talking square root wise, 3 and 4. So those are the actual two whole numbers. So it would probably be, if you put square root of 10 in your calculator, it would be 3 point something. All right. Square root of 23, what do you think? Irrational. What two numbers do you think it'd be between? 4 and 5. So in other words, square root of 16, square root of 25. Now, why am I telling you guys this? Why am I making you do like the whole between two numbers thing? It's just a way that you can guesstimate where that number would fall on a number line. All right, that's how you think about it. So if you have to ask yourself, okay, where would square root of 10 be? Okay, I know, well, it has to be between square root of 9 and 16. Well, if I take the square root of those two numbers, that's 3 and 4, so it's probably 3 point something. All right. Now, so basically, square root of 28, what two integers would it be between? 5 and 6. Because that means it has to be between the square root of 25 and the square root of 36. Now put that in your calculator and tell me what you get. All decimal places. Is that between 5 and 6?
Yes.
0.29. 5.29. All right, so now, in all honesty, I don't care about all the decimal places. I just want to make sure that it's between 5 and 6. All right, we're on page 4, Roberto. Now, simplify this radical. So what is the largest perfect square that's a factor of 28? 4. So I can rewrite this as 4 times 7. So square root of 4 times the square root of 7. What is that simplified? 2 square root 7. So if you put that in your calculator, do you get that? Yep, and I'm not rewriting it. I just drew an arrow. Now, last thing we got to talk about, some basic operations with irrational and rational numbers. So from the looks of it, from simplifying, a non-zero rational number times an irrational number results in an irrational number. For example, this one right here. We have 2, which is a rational number, and square root of 7, which is an irrational number. When we multiply them together, did we get a rational number or an irrational number? Irrational. All right. So no matter how you swing it, rational times irrational is irrational. All right. All right. Now let's talk about addition subtraction. So let's just take a guess. If you add a rational number and irrational number, what type of number do you think you're going to get? You guys said irrational, right? You're right. Why?
Because two negatives don't make a positive.
Yeah, so let's think about it this way. Let's say that I was adding 1/2 to pi. So 3.1415, et cetera, et cetera. It would only change the first decimal place. All right. So if I add 3.1415, et cetera, and I add 0.5 to it, all it would do is change that decimal place. So the very first decimal place. Everything else will keep repeating forever and ever. So yeah, of course, if you add a rational number to an irrational, you get an irrational. All right, so that's true for all of these. It's irrational. This one's irrational. This one's irrational. You can put that in your calculator and see it as well. Because if you put in your calculator, do 7 minus square root of 8 real quick. So do 7 minus square root of 8 in your calculator. So if we look at this number, is there a clear pattern of the decimal places? Nope. Looks pretty random to me. Is there a terminating into it? So is there end in sight? Nope. All right. It may look like there's an end in sight, but that's just as many numbers your calculator can produce or fit on its screen. So it's still irrational. So when a rational number is added to an irrational number, the result is always irrational. And that's just logically makes sense. So look at this last one. Which one's the only one that gives you an irrational number? Why is it 4? Right. 1 square root of 25, that's 5. 3, it's already a fraction, so it has to be rational. 4, square root of 9 is a nice number. So 4 minus 3, which is just 1. So just because there's a radical in it does not mean it's necessarily irrational, because they may throw a perfect square under that radical. So it's 4. All right. So that's it for notes for today. Just in time, too, because my computer's about to die a horrible death. So here's what we're going to do now. Now, just so